it turns out comments automatically.
Does it really?
Yeah.
But can anyone access it?
Yeah.
So like
Yeah.
parents can access it and
Yes.
stuff?
Yeah. It's still on normal YouTube as well.
But YouTube Kids is hard to download. It takes slower to download stuff.
We'll
But
see,
it's
we'll
still on
see,
regular
we'll see.
YouTube as well.
One of these days when we have nothing to do, which may come up, like if we get like, remember y'all got done with your quiz early?
Mm-hmm.
So when we have those days, y'all can help me fix my YouTube channel. Okay, so let's get started because we got a lot to do today. 4.4, least common multiple. Okay. Now, here's the thing about least common multiple. Excuse me. It is going to be done. Well, by the time we're done with this today, you're going to be thinking greatest common factor was a lot easier.
It is a lot easier.
Oh yeah.
Okay, so
It is.
all right. In fact, I'm going to do examples, but I've never really done a ton of examples. But I can. I can do several examples.
I think we learned to do this last year.
Wait, so that means we're gonna have a lot of problems. Are we gonna have a lot of problems to do, like in the book?
I don't know.
Also.
Okay, let's get started. But if you pay very close attention, okay, I just taught 6th grade this. If 6th grade can figure it out, my 7th graders can. But you got to pay close attention, okay?
I think Coach Cole told us last year, just write out all of the multiples and then find the least common multiple.
No.
Or something like that.
That will work with small numbers.
Yeah.
Okay? Big numbers, or if you have 3 numbers you got to compare, that's hard. So we're going to do factor trees again. Okay, I like factor trees. Okay, here we go. Least common multiple of 2 or more numbers is the smallest number that is a multiple of each of the given numbers. Okay, so least common multiple of 2 or more numbers is the smallest, hence the word least, smallest number that is a multiple of each common given number. So it's just like greatest common factor, but this time we're dealing with multiples. You got to remember what multiples are. Like the multiples of 2 would be 2, 4, 6, 8, 10. Multiples of 10 would be 10, 20, 30, okay,
And so on.
and so on. So, but we're trying to find the least common multiple. Okay, so this is helpful when you're adding and subtracting fractions or comparing fractions. Because you know you have to get a common denominator to add and subtract fractions. Well, like my 6th graders right now are doing that. They're having to get common denominators. And instead of getting the least common, they're just getting a common denominator. So they're working with big numbers. So you can still solve it and get the same answer, but you're dealing with a lot bigger. So least common is more helpful when it comes to that. Okay. I'm very loud, I notice. Find the least common multiple using exponential form.
We can hear you whenever we're in that class, like clearly.
Oh, really?
Mm-hmm.
I can't.
I can whenever Coach was teaching.
Oh, over my voice?
Yeah.
Like worse than he is right now?
Yeah, we can hear clearly what you're saying. Like him, I can really hear mumbling.
I can't hear anything.
Okay, so here we are. This is the important stuff. Find least common multiple using exponential form. This is like what we did with greatest common factor. Very specific rules here. Step 1. You're going to write the prime, I'll talk in less, factorization of each number. And I'm going to say same as greatest common factor, and we're talking about factor trees. Okay, so step one, you're doing factor trees, and then you're going to write the prime factorization of each number just like we did with GCF. You do the factor trees. You know how you list out the prime factors and then you put them in exponential. Oh, yeah.
Why are they called factor trees?
Because when you do those little things, I don't know, I guess they say it looks like a tree.
Like, you know, like how on a Christmas tree, how it goes.
Oh yeah, that's true.
Okay, so the first step is to do a factor tree. Second step is to write in exponential form if needed. Again, just like you did when you did the prime factorization. Now, with greatest common factor, we did not do this. We did not put it in exponential form, okay? We just wrote it out and then we circled our pairs. Do you remember that? Okay, so with GCF, we just wrote all the prime factors out and then we circled our pairs. With least common multiple, you're going to write it in exponential form, just like all y'all did with prime factorization on the quiz. And then 3, here's the important part. Find the product. What is product?
Answer to a multiplication problem.
There you go. That means multiplication. I can even put a little X there.
Instead of division.
Yeah, very good. You're learning. So find the product, because you know when we write it out, we multiply everything, just like we did with GCF and prime factorization. Of all, here's the key word, all the prime factors that are represented, here's another part, using the highest powers of each. And powers, I'm referring to exponents. Okay, so using the highest powers of each. Highest, I'm going to box that.
What do they mean by highest?
Well, you're about to find out.
Okay.
You think this is very important?
Yes.
Have I made that clear?
Yes.
Okay, so the third step 1 and 2, you guys have already been doing. Okay, y'all understand that. Step 3 is unique only to least common multiples. You find the product of all the prime factors that are represented using the highest powers of each. And I'm going to explain that in just a minute. Okay. Now, let's review real quickly. I'm sorry. All right, so the example I'm going to give you is not of this. It's just to show you what we're doing in a different way. So let's say I want to find the least common multiple for 9 and 6. So Tanner, what are my multiples? Give me 5 multiples of 6.
6, 12, 24, no, 18, 24,
What's 5 times 6?
Oh, 30.
There you go. Okay. Now, Joseph, give me 5 multiples of 9.
9, 18, 27, 36, 45.
Do y'all see a least common multiple? Do you see a multiple
Yes.
that they both have in common?
Yes.
Joseph.
18.
Okay, so the least common multiple is 18. That is what we're looking for. However, it's not going to be that easy. This is what you did in the past for the most part. In fact, to the point that in 6th grade when I taught this, I spent more time on this stuff than I did on here because I know this is the last year they'll be able to really do this. You know what I'm saying? So I made sure that they learned this method to prepare them for whatever teacher they have next year. Okay, so we could keep going and find another multiple, but would it be the least multiple? No. Okay, any questions so far? All right, let's keep moving. All right, so here we go. Here's the big stuff, the big ugly. Find the least common multiple of 30 and 45. All right, here we go. Did someone make a comment on the Google? Did you make a comment? I tell you, did you? I got a notification from Google Classroom. I was just wondering. Okay, so step 1 basically says make the factor tree. So here we go. Step 1 is go ahead and make the factor tree. So what 2 numbers, Natalia, gives me 30?
15 and 2. Or, yeah.
Okay, 15 times 2. And y'all know we could do 3 times 10 or 5 times 6, but you can choose whatever. 2 is prime, 15 is not, 5 and 3. Good job. Okay, Talia. How do you do that? Is that how you do it? Is that a heart? No, it goes like this. See, I'm old. Okay. All right.
15 and 3.
Well, why do you have to be so difficult?
Second.
That's so not what I always. You think of the hardest ones.
That was the easiest one I could think of.
See, that's not the first thing I think of. I'm over here 9 times 5.
Exactly.
Yeah, see, Joseph and I get it. Okay.
I wasn't thinking either of those.
Okay, so here we go. So step 1 is to do the factor tree and write out our prime factors in order from least to greatest, just like we did with prime factorization and GCF. Make sure you cross out your prime factors after you've used them. Okay, so this point, I'll let y'all catch up. This point, you guys understand. We've done this part, okay? However, step 2 says to write them in exponential form if you can. So please watch. This is very important. I'm drawing arrows. Now, is there anything here that I can do in exponential form? That I have just 1, 2, 1, 3, and 1, 5. So Talia's right. There's nothing. I almost called you Natalia. See, I play around, then it becomes a habit. So there's nothing I can do differently in exponential form. Now, Joseph, can I write this in exponential form?
Yes.
What?
3 to the second power times 5.
Excellent. I have 2 3s, so I can write that as 3 to the second power times 5. Okay. Any questions so far? Please tell me if you do not understand what we did right here. Yes?
Why do we have to do that?
Okay, so this is step 2 to find least common multiple. It says write in exponential form if needed. Okay, so like this, it's not needed because you can't do it. Here we can. We have to put it in exponential form so that we can do 3. Step 3 says find the product of all the prime factors. That's different from greatest common factor where we only did pairs. Now we're dealing with all that are represented using the highest powers of each. So it says all. Oh, Siri. Oh. Okay. So it says all prime factors. Here's step 3. Y'all pay very close attention. Pay very close attention. It says all prime factors. So we're going to start with the smallest. Atalia, you watching? I have a 2 here. Do I have any other 2? I'm going to circle. That's the highest power then of all the 2's. That's the highest power of all the 2's. Okay, Atalia, I have a 3 to the 1 and a 3 to the 2. Which is the highest power? So I'm going to circle that one and I'm crossing that one out. See where I'm going with this? It says all of the prime factors, so we're going to hit on every single prime factor, unlike greatest common factor where we just circle the pairs. Here, we're dealing with all of them. So we looked at the 2. This is the only 2. It's the highest power. Circle. We have a 3 to the 1 and a 3 to the 2nd. This is the highest power of the 3, so I'm circling it and crossing out that. Now I have a 5 to the 1, because remember, if there's no exponent, we pretend there's a 1, and a 5 to the 1. They're the same power. So I'm going to just choose 1, a random one. I always choose the 1 on top, just out of habit, and I'm going to cross out that one. So when you're comparing numbers for least common multiple, you're going to choose each prime factor, but the highest power of each. Now I'm going to rewrite it to, so I'm rewriting it, times 3 to the 2nd power times 5. So I'm going to cross out the ones I just wrote down. Do y'all see what I did? I took the ones I circled and I wrote them out, multiplied by each. Any questions so far? Okay, so what is 3 squared? Go ahead, Tina.
9.
Very good. All right, so who can tell me what 2 times 9 times 5 is? Raise your hand when you have the answer. Atalia? 90. There you go. That is least common multiple. You're taking, this time, instead of just like greatest common factor, we would have just taken a 3 and a 5, multiplied them, 15. We would have not used the 2 and 3. But least common multiple, we're using all the prime factors, but the highest power of each. Let's do another. Any questions? Really, least common multiple is one of those things where you just need to practice it over and over again. All right, example. Find least common multiple of 12, 28, and 75. 12, 28, 75. See what I'm saying? You could sit there and be listing multiples all day long. But we could just do factor trees. All right. Once you have this written down, I'm going to call on each of you. I have 3 students, so I can call on each of you. Tanner, give me 2 numbers that would multiply, give me 12.
6 and 2.
6 times 2. Circle the 2 because it's prime. What? And then 2 times 3. Atalia, what about 28?
4 times 2. Or sorry. 14 times 2.
I knew you'd do that. I knew you'd do that. 14 times 2.
What?
I'm over here 4 times 7. Okay. And then
7 times 2.
there you go.
I was trying to come up with a different one. But
I know.
couldn't
I
think
know.
of
You're
one.
trying to be all fancy.
Well,
Okay.
for the other ones, that's what my.
That's how your brain works. And I love it. Joseph. Huh? 15 times 5. I should have given Atalia this one.
I thought he said 50. I'm like, what?
What?
And then
3 times 5.
very good.
I know, I was going to do 25 times 3.
You would. Okay.
What's wrong with that?
All right, here we go. Here we go. So we understand this, correct? Okay, so now we're going to write it out. And remember, we're going to go step by step, just like with prime factorization and greatest common factor. Nice and neat. That's the one thing about this class is you are pretty thorough on your stuff. Okay, put your pencil down when you get to this point. Okay, you have a question?
Yes, ma'am.
Yes.
There's no 3 on the middle row.
That's okay.
5 on the middle row. So
Okay, that's good. That's why I have this as an example.
So it's 1.
No, there's no 1. This is not greatest common factor. Okay.
No, that's what I'm saying.
All right, so Tanner, can I write the prime factors of 12 in exponential form?
Yes.
How would I do that?
2 to the 2nd power.
Times
3.
3. Good job. Atalia,
2 to the 2nd power times 7.
and then Joseph.
3 times 5 to the 2nd power.
Okay, so I'm going to stop right there. Y'all write that down and raise your hand if you have questions about what we just did. Okay, now watch carefully. Unlike greatest common factor, it doesn't matter if there's a 2 down here. We're going to go each prime factor. So we're going to start with 2. 2 squared and 2 squared. No. Which one do I circle?
Oh.
Tanner?
1 of them.
One of them, because they're the same power. So we just circle one of them, and I always go for the top number, just out of habit. And I'm going to cross out the other one. Now I have the next prime factor, I have a 3, because I go in order, and a 3 down here. Which one do I circle? Raise your hand. Atalia? Either one. That's right. And I always go for the top number and cross out the other, because they're the same power. Now I have a 5 squared, and I don't have any other 5s. So what do I circle? Tanner?
7.
We're dealing with 5.
Oh, sorry.
I have a 5 square, but I don't have any other 5s. So
You
what?
just circle that one.
That's right. And then I have a leftover 7. What do I do with that, Joseph?
Just circle it.
That's right. We don't cross it out. Good job. Man, y'all are getting this better than any other class I have ever taught this to. All right, so I'm going to write this in order. 2 squared times 3 times 5 squared times 7. So I wrote out all the things I circled. Atalia, what is 2 squared?
4.
Times 3. Joseph, what is 5 squared?
I scored 5 times 5.
Which is?
25.
And then times 7. And I'm going to save y'all time. The least common multiple is 2100. So y'all would be writing out multiples for a long time before you found the one that all three shared. See why this is important to learn?
The other day I was doing the Excel for this,
Uh-huh.
and I was sitting there in class, and I got to over 1,000. Sitting there writing them out. Remember that?
Now,
It was only 544, but still.
but it takes forever. This is quicker. Any questions? Y'all are catching on. All right. Let's move on. I'm going to do another example. Okay. Find LCM of 12, 18, 24.
We already did 12, so we can just do that one.
Well, we're still gonna.
That's my tactic. If I've already done one, I just
Hopefully you did it right. Okay, since we already did it, we'll just go ahead and copy it from the other page. Shh.
Can I do 18?
All right, Atalia, you can do 18,
6 and 3.
and then
3 and 2.
I wrote
Joseph, you want to do 24?
Yes.
What?
12 times 2.
There you go. That's a Atalia kind of thing.
What's wrong with 12 and 2?
Nothing. I'm just playing around. All right,
6 times 2.
and then
3 times 2.
4 times 3.
all right.
4 times 3.
Yeah, that's what I'm saying.
Let's write these out. And then I'll hold up and let y'all catch up. Make sure that you're crossing these out as you write them so that you get all of them listed. I'll wait for y'all to catch up. Put your pencils down when you get to this point. All right. Tanner, what is the exponential form for this?
2 to the second power times 3.
Natalia
2 times 3 to the second power.
and Joseph.
2 to the third power times 3.
Okay, write that down and then look at the board. Now, I have 2 to the second power, 2 to the first power, and 2 to the third power. Which one, Natalia, do I
2
circle?
to the third power.
Yes, ma'am, because it is the highest power. And I'm crossing out the others. Tanner, I have 3 to the first power, 3 to the second power, 3 to the first power. Which do I circle?
3 to the second power.
And cross out the others. You guys rock. I mean, I may not need to do too many examples in the book because you guys are just killing it. So 2 things were circled. Yeah, I mean, y'all are. This is incredible. I've never had a class catch on this
The
quick.
very last part kind of confuses me.
This part.
Yes, ma'am.
Okay, so 2 to the third power. That is 2 times 2 times 2. So Talia said it's 8. And see, it's 2 times 2 is 4. 4 times 2 is 8. So this part confuses you?
Yes, ma'am.
And then 3 to the second power is what, Joseph?
3 to the second power is 3 times 3.
Which is?
9.
That's right.
9.
Look, Tanner, if you understand all of this, and this is your only issue, you're in good shape. Yes, Ataya?
I know what to do.
What is it?
72.
So the least common multiple
I could have said it.
is 72.
I did first.
So, Tanner, do you understand why 2 to the third power is 8?
Yes.
Okay.
I just got confused on like, did we multiply or add?
Okay. If that's your only issue, you're in good shape. All right. Any questions?
No.
No, no.
Now let's throw in some letters
Oh.
Oh, boo.
of algebraic
Expressions.
expressions. That's letters. Let's do 15 x to the third power y and 21 x to the power 2. I'm serious. I think I'm going to do this example and then one more. I'm going to set y'all free. All right. You have a question? Okay, so just like in greatest common factor, we're only doing the factor tree for the numbers. So, Talia, what is 15?
5 and 3.
Let me circle it. And Tanner, what is 21?
3 and 7.
Okay, so that's the same as greatest common factor. So now I'm going to write it three times 5. Now, here's where it's different. Remember, in greatest common factor, we do x times x times x times x. You don't need to do that here.
Keep the exponent.
You keep it in exponential form.
Interesting.
Why?
Because we're dealing with exponential forms now. And then 3 times 7 times x squared. Can I write this in exponential form, Tanner? Either one of these? So they're already done, pretty much, right? Okay, so I don't need to rewrite anything. The letters you keep in exponential form. So, Tanner, I have a 3 and a 3. Which one do I circle?
1.
I'm going to do the top one and cross that out. Natalia, what's the next thing I circle?
X to the third power.
What about the 5 and the 7?
Oh, well. Okay, you circle both of them
Why?
because they don't have another one that's a whole higher power.
That's right, because they are the higher power. Do y'all see that?
Yes.
Now, Italia, I have x to the third power and x to the second power. Which one do I circle?
X to the third power.
That's right. You treat it just like we've been doing it. And then, Joseph, what do I do with this y? So then, I have 3 times 5 times 7 times x to the third power times y. And 3 times 5 times 7 is 105 x to the third power y. Any questions?
So we would only, just trying to clarify, we would only multiply 3 times 5 times 7. We wouldn't do any of the x times y.
Well,
We
that's,
want the equal.
yeah. There you go. Any questions? All right, I got one more. Y'all ready?
Kind of scared.
We're going to do one from the book, and then that's it.
Really good. What?
Because y'all, I think y'all are ready. Look at 34. And let's move fast so y'all have time to work on this.
What page? Oh, wait, I'm sorry.
I'm writing this out. Y'all open your books.
Oh, goodness. Okay.
Don't let this scare you.
Excuse me. Like, kind of feared.
We're going for the big ugly. You figure this out and we're good to go. All right, so write that down.
I
It's
don't
number.
think it has a difference between the other ones.
It just looks worse.
Yeah.
Too much.
And keep in mind, your letters are already in exponential form, so there's no work to be done there.
Is that a 2 or a Z?
These are Z's. Z's are Z's.
Z's or Z's.
These are Z's.
Sounds like Edna mode from
All right.
Incredibles.
I want to get this done in 5 minutes.
Is that a 6 or a B?
6.
Okay.
And that's a 5. And that's a 7.
Maybe.
All right, Joseph. Do 16. Did you write all this down?
Yes, 8 times 2,
All right.
4 times 2, 3 times 2.
All right, Atalia.
8 times 8. 4 times 2.
And then 4 times 2.
And then 2 times 2 times 2.
We'll let y'all catch up. And then Tanner.
6 and 6. And then 3 and 2.
And 3 and 2. Good job. Okay. I'm going to rewrite these.
Just realized they all have 6s in them.
Okay, so here I have 2. Cross out 2. And I'm going to wait before, I'm going to wait before I write my letters.
I haven't even finished writing the numbers out yet.
I'm going to wait before I do that. So I can put them in exponential
I
form.
thought it was just the 50th power for a second, or the Y is.
So I'm just doing the numbers first. And then when I put it in exponential form, I'll add the letters. So y'all get to this point.
I thought that said 3 or X to the 50th power.
Oh yeah, I see that. All right. Tanner, what would the exponential form for this be?
2 to the 4th power.
And then I'm going to go ahead and write my letters.
It's kind of hard to see which letters you're on.
So I'm writing the letters at the end of these of the exponential for 2.
A lot of writing involved in this.
Okay, Atalia, what is the exponential form for this?
2 to the 6th power.
X to the 3rd times y times z. And then Joseph,
2 to the 2nd power times 3 to the 2nd power.
times x to the 5th power times y to the 7th. Make sure you write that down. Any questions so far? Joseph, any questions? All right, Tanner. I have 2 to the 4th power, 2 to the 6th power, and 2 to the 2nd power. Which one do I circle?
The 2 to the 6th power.
Yes, ma'am. It's the highest one.
6 was also a 2.
Good job. She circled 2 to the 6th power. It's the highest one. We're crossing out the others. Atalia, I have 3 to the 2nd power left. What do I do with it? Circle it because it's the only one left. Now, Joseph, I have x to the 5th power, x to the 3rd power, and x to the 5th power.
Circle one of the X to the 5th power.
That's right. I'm going to do the top one. You circle one of the x to the 5th power because it's the highest. Tanner, I have y to the second power, y to the first power, y to the seventh power.
Y to the seventh.
That's right, y to the seventh, that's the highest. And then Natalia, z to the fourth and z to the 1.
You did the fourth.
All right, now I'm writing out my circle, 2 to the 6th power times 3 to the 2nd power times x to the 5th power times y to the 7th power times z to the 4th power. Just to save you on time, you multiply those out, you get 576, x to the 5th power, y to the 7th, and z to the 4th. Any questions? You guys rock and roll. I'm going to go ahead and get y'all started. I won't be too harsh. Numbers 17 to 21 odd. That's 3 problems. Actually, 25. So that's 5 problems. So 17 to 25 odd. And then 29 and 31. What is that? 7 problems. Due Wednesday. IXL, due Wednesday. Any questions? Get started.